in this video a kind of update on the metal detector project. In a certain way it has succeeded. I've used another type of oscillator and say the 3-transistor amplifier that does the job of amplifying the clicks out of the oscillator. The clicks are realized by using an electrolytic capacitor to the output of the 3-transistor amplifier. So it means that the whole oscillator circuit is in a certain way hicking, and that makes it sensitive. Anyway, I will demonstrate that a little bit. I cannot publish it now on YouTube because I have not tested it with a moist soil or a dry soil. Of course, when you have such an open coil here, moisture will have an enormous effect on the frequency where the whole circuit oscillates. It damps the frequency. Could be that the whole oscillator stops purely due to moisture. So it only works at this moment with, say, in a dry situation. Anyway, let's try the pickup coil. Here is a piece of metal, a bin, metal bin. Move it now here to that metal bin, and you can see that the oscillator, say the clicking, stops. So it works on a distance of approximately 20 centimeters, at least in a dry environment. So anyway, that's more or less the first thing. The second thing is that I made a very easy beeper circuit with 2 transistors here. This is the schematic out of the 1972 magazine found on worldradiohistory.com. Of course, the capacitor here is dependent for the sound that you hear. I did a few first experiments, and perhaps you can ask, why do I publish these very simple circuits? The only idea is that my YouTube channel is for a certain part meant to make the electronics popular. And say suitable for everyone wanting to do simple experiments with electronics, though I have to say that on the same moment there are also quite elaborated circuits on my YouTube channel. When you want to find them, go to my channel trailer Radio Fun 232 on YouTube, go to the looking glass and type there the keywords about the electronic circuits that you want and need or like. Say audio, amplifier, radio, filter, audio filter, VLF, measuring. That are, say, in a certain way the keywords. Anyway, I want to demo now this 2-transistor easy beeper circuit. Standard problem with all these in a certain way 2 simple circuits, that they are not always self-starting, especially when the voltage is slowly lifted up from 0 to, say, 9 volts or so. But this circuit can be made in such a way that it really always starts to beep. And of course, now we live in modern times, 2026. Many simple computer, not simple, but anyway, say Arduino computers work on 5 volts. So I tested this in a broad voltage range, going from say 0.8 volt up to 9 volts. I did not go higher because there was instability. You can surely find that out better, for instance, by using here a smoothing capacitor in the order of 100 microfarad. It will help to stabilize the circuit. Anyway, on 0.8 volt I got to this frequency band, 700 Hz up to 16 kilohertz. On 5 volts I got from 500 Hz to, this is also 700 Hz, 500 Hz to 1.9 kilocycles. That's in the audio range, and an annoying sound on 6 volt this frequency band, and on 9 volt 18 kc. But interesting is that on a very low voltage you can get to 16 kilocycles. That's it goes to the ultrasound range. Anyway, circuit again. Of course, when you change this capacitor to say 0.47 microfarad, that is 470 nanofarad, you will go to a completely other frequency range. And in the original circuit, there was no potentiometer, but I always use it because in that case you can get this circuit on different frequencies, always into oscillation. When you use fixed value resistors, like in the old schematics of the 1960s, it could be that it doesn't work. But when you use this, it more or less always works. Anyway, so what's more to tell? We are now on 5.5 volts. We have a good annoying sound. We have this waveform. You can see that it consists of very sharp peaks, very strange. It is on 369 Hertz approximately. So let's change the voltage first, but earlier let's see whether this circuit always wants to start, and that is of course important when you want to use it in an Arduino application or so. So here, take out the voltage, but when I add it, it must start. And it works nice. Thus it also starts when the voltage to that oscillator is slowly going up from 0 volts to say 9 volts or so. Let's try here. Now it works. We are on 1 volt, 2 volts, 3 volts and 5 volts. Let's go to 9 volts. I hope that it still works. Well, here there is a kind of problem. It works now on 7 volts. This is the waveform. This is the frequency, say, well, it starts to be a bird. Interesting. 3 kilohertz. But say the only thing that I want to tell, it's a useful circuit. You can use it for different frequencies. Do your own experiments. The circuit is very simple. It can also be made by beginners. Change this capacitor, change here, do some adaptations by turning that potentiometer here. I want to demo it when I can find a suitable screwdriver. Let's try. that bias potmeter, when I touch it, the frequency changes. That's a very good say property of the circuit. We are on 3.8 volts. Well, I have to find the right screwdriver. And here it stops suddenly. And here it is to the lowest frequency here. So the bias changes and the frequency changes. And that's also the reason why I advise when you do certain electronic experiments and you find fixed value resistors to set the bias of a transistor, one transistor, use a potentiometer and check the output of what is happening in that circuit with the oscilloscope. Thanks for watching. I don't want to make it too long, but there's a lot of fun, of course, when it works. And when you look at the waveforms, they are extremely important. Anyway, thanks for watching again.